Okay, so today we're going to have a little look at 14C, which is applications of geometric sequences and series. We're going to look at two different videos. We're going to have the first video which looks at investments or loans which have a percentage applied to them over a number of years, and it accumulates over time. The second type of examples we're going to look at is if you had an investment or a loan and you paid off part of that loan over time, how that would affect the outcome. So the first example we're going to be looking at is Elena invests $3,200 at 3.2% per annum compounded monthly. Compound interest you've been looking at since grade 9, and we have the formula A, so the total amount is equal to the principal multiplied by 1 plus I, where I is your interest rate, so the decimal version of the 3.2%. Multiplied also to the power of n, where n is the number of periods this happens for. We need to always make sure that I and n are in the same time period, and if we go back to the question, we are told it is compounded monthly, which means we actually need to convert these into months. So at the moment my 3.2% is annual, so I actually need to divide this into 12 equal sections, so it's monthly. And I need to multiply my time period by 12. So if this is years, we need to make sure that whatever is going in here, though, must always be given in terms of months as well. So looking at our question then, we're going to get 3,200 multiplied by 1 plus I, which is 0.032, divided by 12, all to the power of 5 times 12, or how many months there are in 5 years. So because we have 5 years, that is 60 months. If we type this in on a calculator, we actually end up with a value. Let's have a quick look. So the calculator says then that 3,200 multiplied by 1 plus 0.032 on 12 to the power of 60 comes out as $3,754.44 to 2 decimal places. So we get this comes out as $3,754.44. Now there's actually a much more efficient way to do this on these calculators. So if you go to menu and you go down to this financial section in the bottom right corner and click on F2 compound interest, we can actually enter in all these values in here, and it does a lot more than and a lot quicker than the formula will be. So if we want in here, n needs to always be the number of periods that this is happening for. So because we're compounding monthly, this needs to be 60. So we're going to type in 5 times 12 in here, which is 60. Our interest rate then is going to be 3.2%. We don't need to write this in as a decimal equivalent. You just write in 3.2. Our present value, PV, is going to be negative 3,200 because we are actually putting this money into a bank account. It's not in our bank account anymore when we invest it. So it's negative 3,200. Our payments, well, we're not making any. We're going to look at that later in future examples. But so that's just 0 for us in this question. Our future value then is what we want to find. We don't know what that is, so we'll just leave that as whatever number's in there. Don't need to change it. Now our PY and CY values both need to be 12 because if we're compounding monthly, the payments are made each month as well. So 12 and 12 for each of those. Now, at the bottom here, we have N, I, PV, PMT, FE. This question asks us to find the value of her investment after 5 years. So we want to find the future value of this investment, F5, which gives us the same answer, $3,754.44. Putting this in your calculator exam, it would look like this. So you would say financial mode, and then you use compound interest. And then you just say what you use for each value. So we had n equal to 60, then it was I equal to 3.2. We had present value equal to negative 3,200. PMT was 0. Future value was what we didn't know. Then we had per years and compounding were both 12 because of the monthly. If it had been just yearly, they would have been 1. But because it was monthly, we write them as 12. And then that gave us an outcome of our future value came out as $3,754.44. Okay, part B then, we're going to use this mode on the calculator, so it's much quicker. Our first thing we want to think about is that the question is asking us to find out how long it takes. So we're trying to find the value of n. So leave 60 in there, it's fine, we'll overwrite it with the new value. We want to know how long it takes for this investment to be worth 15,000. So our I is staying the same, our present value is the same, monthly payments are 0, but our future value is now going to be 15,000 and positive 15,000 because it's going to be ours at that point. That's what we would make if we'd put this investment in place. Then our per year and compounding are still the same. We now are looking for our time period n, so we click F1 and we get told n is 580. So in order for this to grow to $15,000, you would have to invest for 581, because at 580 it wouldn't have made 15,000 yet. So you'd have to invest for 581 periods. And in this case, our period is months. So in order for this one to be, we would say, okay, the answer is then going to be 551 months. Sorry, I think it was 81, wasn't it? 581 months. And again, you would write your workings out in a similar fashion. So we would have n equals question mark, I equals 3.2, PV equals negative 3,200, PMT equals 0, future value this time will be positive 15,000, per year and C year are both going to be 12, and therefore we got n was approximately, it was about 580.1 months, so therefore we said it would take 581 months to reach $15,000, and you would write that into a sentence. Okay, example 2, we're going to use our calculator again for this one. Slightly different though this time. We're looking at a car was bought for $2,500 and it depreciates at a rate of 7.5% per annum. So it drops by 7.5% every, it will reduce the value that's left by 7.5% every year. So going back and looking at our calculator, our first thing we want to look at is what will be the value of the car in 6 years' time. So this will actually be 6 now. We're not anything fancy because we're not doing this on a monthly basis, it's just yearly. So n is 6. Our interest rate then is going to be 7.5, but more crucially this time, because we are depreciating, we need to write in negative 7.5 in here. Our present value, well, the car is worth $2,500. So let's do that. I think that's meant to be 25,000. Let's just write that in as 25. $2,500 is a bit of a cheap car. Let's go for 25,000. Let's cross that out. So 25,000 in here. So 25,000. Then payments, we're not making any payments. Future value is what we want to find. So leave that as 15, whatever's in there. Our payments are once a year and it will automatically then change your compounding period to match. We want to find the future value of the car in 6 years' time. So if I now go FV, we can see the car is going to be worth $15,659.95. So again, you would just go through and write in each of those things. But for the first value, A, it's going to be worth $15,659.95. For part B then, we can see it says after how many years will it take for the value of the car to drop to 50% of its original value. So if we go back, we can then use this. So our n value is what we do not know because we want to find out how long it takes. Our interest rate is still dropping at 7.5% each year. Car is still worth 25,000 to begin with because we own the car. That's why it's a positive 25,000. And what we're going to say then, payments are 0, future value. So we want this future value to be worth half of this. Now, you need these two to be opposite. So if that one's positive, this one you have to enter in as negative. If you didn't, I'll show you what happens. So half of 25,000 is 12,500. Payments per year and compounding period hasn't changed. If I now try and solve for n, which is what we want to do, we want to find how long does it take to reach half its original value. If I press this, you can see it says invalid setting. So that gives you a little hint that there's something wrong here. So we actually needed this to be negative 12,500. If I now press N, we can see that's now giving us a nice answer. So N in this case is coming out as 8.89 years. So N equals approximately, I should say, not equals, 8.89 years. So we can then say, okay, how long will it take to drop to 50%? So therefore, it will take, the pen will work, 9 years to drop to 50% of its original value. So that is how you use the calculator function to answer these questions. And we're now going to have a look at what happens when payments move to be, instead of 0 each time, we're going to look at what happens when payments are more than that.